Okay, gang. Half an hour. This problem is like a half an hour or more long, but here we go. Part C. As we hang in there with this, it's like climbing Mount Everest. Okay, maybe not that bad. That was definitely sarcasm. So we're now going to find the angle between the ladder and the wall. Okay, now make sure you get that in the right spot. Make sure you find the right spot for that. By the way, just I wrote a little note to you guys, but the part B, A is 2 dimensions, so that's why that's feet squared and not feet, right? Area is like surface, so that's 2 dimensional. So you can't write feet per second. You have to write feet squared per second. All right, I corrected myself by writing you guys a little note, but just make sure you caught that. All right, back to business. All right, the angle between the ladder and the wall. This is the ladder, and this is the wall. So it's this angle here, okay? You want this guy here. Don't put the angle here. This angle here would be between the ladder and the ground. This one's the ladder and the ground. This one's the ladder and the wall. So the angle is here. You got to get in the right spot. It's not a free-for-all. It can't sit wherever it wants. All right, now whenever you have an angle, you need to use your trig from pre-calc, right? Trig from pre-calc. So there's a couple ways to do this one. I think I'm going to go with the tangent. You don't have to do that. You could go with another trig function. All right, so I'm going to do the tangent of theta equals the opposite over the adjacent. All right, that's just me. That makes me happy. That may not make you happy. So do what you like. All right, so that is off the general. Right, this picture here is the general. Let me just go ahead and take the derivative, and then I'll pick apart the rest of what they're asking. All right, derivative of tangent is secant squared of theta. That's the derivative of the tangent. The derivative of theta itself is d theta dt. All right, I'm going to go with quotient rule. So denominator times derivative of the numerator, bottom times the top minus the top times the derivative of the bottom over the bottom squared. Okay, that made me happy. Again, if that's not you, you do it your way. And we're doing the base of the ladder 7 feet from the wall again. Oh, that's awesome. Okay, that means that all the previous stuff we found carries over. And so what I mean by that, God, I almost need a separate sheet for all the information. Okay, so because they're using 7 feet again for the base, we can carry over all that stuff. So we know for specific information, we know this is 7. We know this is 24. We know dy dt is -7 over 12, and we know dx dt is 2 feet per second. I don't think we're going to need dA dt. No, we're not. Okay. All right, so this is like all from the previous parts, okay? All right, so we are looking for the rate of the angle. So we're looking for d theta dt. So I'm now going to isolate what I want, which is d theta dt. So for me to do that, that's not too difficult. I just have to bring this down. So I have to divide by secant squared of theta. You could flip that up as a cosine squared. It's just up to you. What makes you happy? Okay, so I've now isolated what I'm looking for. Let me just make sure I wrote a y there. I did. Okay, now I'm going to plug in. And again, make sure when you plug in, that's off of your specific. And you may have to sort of figure out stuff as you go. And you just sort of, you have to be able, you can't have any unknowns when you're trying to solve, right? So if you're missing something, you got to go find it. So I think I have almost everything here. All right, so let's plug in. So y we said was 24. I'm just looking, when you see me shift the paper, I'm just looking at all this specific information. It's like, this needs a lot. All right, so y we said was 24. dx dt we said was 2. X we said was 7. dy dt we said was negative 7 over 12. Y again was 24. All right, now remember this means secant theta quantity squared. Okay, I just want to make sure you understand what they're saying. You might look at that and be like, what the heck is that? How do we find that? That's not hard at all. That's not hard at all. It just depends how your brain is processing that. You know that this is theta. You know that this is theta, right? So if I ask you for secant theta, I know we need squared, but let's just start with secant theta. You know that that's going to be the hypotenuse over the adjacent. So this is a hypotenuse to the angle, right? Because it's across from the 90. And to the angle, this is the adjacent side. This would be the opposite side. All right, so if I want to do the secant of theta off of this triangle, it's hypotenuse, which is 25, over the adjacent to the angle, which is 24. So it's 25, 24. Now just be careful, because when you write 25 over 24, you have to make sure that you write that it is quantity squared, okay? All right, so that may have looked really difficult, but it's not that bad. Everything I'm saying is relative, okay? All right, now let's start to simplify this beast. We got this. All right, 24 times 2. Today it's 48. Again, that's my sarcasm. Negative times a negative is positive. 49 over 12. Now, I don't know if I need to write this extra step. I'm gonna. You may not need it. I'm actually sure you don't need it, but I'm gonna write it anyway. When you break this up, this is 25 squared over 24 squared, right? Like this. But this cancels with this. It's the same thing. All right, so now I have 48 plus 49 over 12 over 25 squared. Now, I'm going to write this as a decimal. If you want to write it as a fraction, that's totally fine, okay? On the test, I don't care which way you write it. So now I'm going to go ahead and crunch this out on my calculator. So I'm doing 48 plus 49 divided by 12. I just like to hit equals here, which is about 52. And now I'm going to divide it by 25 quantity squared, and I'm getting about 0.083333. So I'm going to write that as 0.083 repeating. Now this is going to sound a little weird if you're not familiar with this. Angles in the word problems are unitless, because if you think of like your chemistry or dimensional analysis, like where the heck would a degree show up? So the default is always radians for angles, because radians are considered like the unitless degree or the default. They wouldn't necessarily come out in analyzing the units. Okay, over time, which is in seconds. All right, so this, my friends, my lovely class, is the final answer. And even better, I'm sure you're thinking, it's the end of the endless, bottomless problem number 21. Congratulations, you made it to the finale. I hope you enjoyed it. I actually thought it was a pretty cool question. All right, catch you, gang. Bye-bye.